Okay, so this lesson, which we're calling Assignment 29b, I'm now doing Part A, number 2. And what we're trying to do here is we're trying to go from f prime. So they're giving us the graph of f prime. And from the graph of f prime, we're actually trying to go back and figure out what the graph of f might have looked like. All right, they're giving us a starting point on f. They're telling us that when x is -1, y is 2. So what I did is I just plotted that starting point on the original graph of f of x. The graph we have here in front of us, this black graph, is f prime. So what I would look for is I would look for special points. So if you notice any x-intercepts, I would highlight them right away. Relative extrema occur at x-intercepts. Drags occur at x-intercepts. So I know right here, something special is going to happen right here at x equals 2. The next thing I would do is I would label the values of f prime as either being positive or negative. So because f prime is positive, it means that f is going to increase. And because f prime is negative from 2 to 4, it means that f is going to decrease. And the special thing that's occurring at x equals 2, at this pink x, is that I have a relative max. Now, what you've created here is, you can think of what you've created here as a sign chart for f prime. And the sign chart tells you whether you're increasing or decreasing or have a relative extreme. What I did not discuss, and I didn't want to overwhelm you, is I did not discuss concavity. So now what we're going to do is we're going to make a f double prime sign chart based on the graph of f prime. So ask yourself, as you're moving from left to right, because f prime is decreasing, all these slopes are what? Well, all these slopes are negative. So now you've created a f double prime sign chart. And if you recall from your previous lesson, if f double prime is negative, it means that your function f will be concave down. So now you know the concavity of f of x. And that's why if you take a look at our starting point, -1, 2, and our ending point at 4, you'll notice that the function in its entirety in this interval from -1 to +4 is always concave down, as your sign chart suggests. Okay, take a look at your f prime sign chart again. Whenever f prime is positive, it means that f will be increasing. Whenever f prime is negative, it means that f will be decreasing. So now what you have is you have a very accurate sketch of the curvature of your original function f. For example, let's take a look at what's happening up to this relative max. Up to this relative max, my function, not only is it increasing, but it's also concave down. So here's your shape, your increased concave down shape. In this interval from 2 to 4, you know that it's decreasing, and it continues to be concave down. So here's your decreasing concave down shape. So the only thing that we have not addressed is we have not addressed the amount of increase or decrease a function may have based on the f prime graph. And actually that's a topic for much later in calculus, once we've actually learned how to integrate. But I just wanted to kind of briefly show you guys something here, and that is, it has to do with the area between the x-axis and the curve. So if the area is above the x-axis, then our function is increasing in that relative magnitude. And if our area between the x-axis and the f prime graph, if that area is below the x-axis, like this red triangular region, then we say that our function is decreasing in that magnitude. So you can see here that the increasing area is what compared to the decreasing area. You can see that the increasing area is more than the decreasing area. Therefore, my function has gone up, see that, more than it has gone down.